So in the past couple of days, I've been decompiling and reverse engineering the Argonaut strategy language interpreter. I managed to crack quite a few OP codes, like add two numbers together, subtract two numbers together, multiply, divide, make a comparison whether two numbers are equal or not, make a jump with the program counter, branch if a comparison is not equal to 0, branch if a comparison is equal to 0, and so on. With these OP codes figured out and re-implemented in C, I managed to log what the strategies are executing in real time by re-implementing the function that the game runs in order to execute the strategy. So while the strategy is not done and it hasn't stopped for any reason, it just picks the OP code, executes it, and increments the OP code. So I managed to keep track and logging what each strategy does, and in special the Harry Potter strategy, which was the one I was mainly interested in. And by logging the strategy, I managed to take some sort of disassembly from the Argonaut bytecode. So here is the bytecode of the main function that the Harry Potter executes. So it starts by pushing the global 126 into the stack. Then it compares if this global 126 is equal to 0. If it's equal to 0, it jumps to this line, otherwise it executes this line. So my idea was that if I have this disassembly and I can if I can re-implement this bytecode in C, I can execute code outside of the interpreter and have the same result in game. And if I have a C code that does the same as the bytecode, I can trash the interpreter and just modify the C code, make modding the game viable without having to create a compiler to compile into the Argonaut strategy language bytecode. So I managed to re-implement this main Harry Potter function from the first level. It's very crude. The variables are not very readable. It is almost like a decompiler output, but this was all manually done since there's no decompiler for the Argonaut strategy language. And I noticed in this script, which I've been studying, that here there is a loop. There is not a loop, a if check with that the first variable is always 0, and it checks whether you're holding a R1 button with a debug pad. So I changed this to be a regular pad. So buttons held. And if I compile this code now, if we save, compile. Well, first I need to change this to be 1, so this first if check works. And I compile the code. And inject in game. You can see that there was a debugger fly code for Argonaut. That's the first time someone managed to trigger it. It's pretty cool. So yeah, thanks for watching.